In this module, we're going to start talking about behavioral design patterns. Now, this is the last of the 3 types of design patterns that we're going to talk about in this course. Behavioral design patterns are concerned with the assignment of responsibilities between objects and how objects communicate. So while creational design patterns were very much interested in newing up an object, such as the constructor method or the factory that were handing me back new instances of an object, and structural were more about adding functionality to an object, and they were all self-contained within an object or wrapping an object and things specifically. Behavioral design patterns break out of that single object mentality and start concerning themselves with interactions between objects. Now, like we said, behavioral patterns deal with the responsibilities of an object, and they'll do things like help objects cooperate. If we've got multiple objects that are trying to accomplish tasks, we have patterns that are going to help objects cooperate with each other to all achieve the same goal. We can also assign clear hierarchy for objects. We can set one object as the object of record, and everybody else watches that object to see when something changes, and then they'll go and do the things that they need to do. We can also encapsulate requests between objects to make sure that requests are being made appropriately, and we can either alter those requests as necessary, or we can change requests to suit our needs. So let's start looking at what these patterns look like and the types of problems that we can solve with them. The first pattern we're going to talk about in the behavioral patterns group is the observer pattern. And this pattern allows for a collection of objects to watch one other object and be notified of changes that happen. The benefit of this is it allows for a loosely coupled system. Now, everything's not tightly coupled together, and you're not actively calling out to different systems. You can allow one object to say, hey, I'd like to watch this object, and that object will then notify it of any changes. One object is the focal point. So in some sense, it's a little coupled because you have one object that knows everything that's going on, and then you have a group of objects that's watching for changes to that object. Now, this one's a little bit more complicated, and we've got a lot of moving parts. So let's take a minute and look at this kind of in slides with boxes so that we can see what's happening in all the moving pieces. And keep an eye out for everything we've talked about up till now, because we're going to use some of the patterns we've talked about up till now to implement the observer pattern. Now, in the example we're going to use, we're dealing with tasks. So we've got our task object. And what we want to implement is 3 services. We've got a logging service, a notification service, and an auditing service. Now, if you remember, over the course of this course, we've dealt with this notification service before, where we wanted the task to notify people, or we wrapped a logging service at one point. And they were always either decorated on or tightly coupled into the task itself. In this case, I want to decouple this so that the task service lets these other services know what's going on, but not in a tightly coupled way. The vocabulary we're going to use for this is 3 words. The first one is observers. The logging service, notification service, and auditing service in this case are called observers. They are going to observe task and watch for changes. Subject is what the task's going to be. And actually, we're not going to mess with tasks specifically in our example. We are going to decorate task with a subject. And the subject basically comes down to a list of observers and a notify method. So what we're going to do is decorate task with a list of observers and a notify method. And what's going to happen when something changes on task, notify is going to send a message to each of these 3 services. And when I say send a message, basically what it's going to do is execute a function that these 3 services have supplied to notify. So logging is going to supply a callback effectively to the observer list, and then when the notify is called, it's going to execute the callback that logging gave to us. So these are the pieces and the moving parts involved with what we're working on. So let's take a look at a practical application of this so that we can see kind of all the moving parts and how this works. All right, because of the complexities of what we're doing here with the observer pattern, I'm going to break out this demo into 4 or 5 different clips. And we're going to just take piece at a time and set up each individual piece, and then we'll see it all working together. So let's start by just setting up our environment. Now, all we're starting with is our task. So I have a task, and it's got name, priority, project user, all that stuff on it. And we've got 2 methods on the prototype, complete and save. So what we're going to do is we're going to create a new file called main.js. Kind of the same way we've been doing this all along. And we're going to require /task. And we're going to set that equal to task. Okay, so we're pulling our task in, and we are going to create and save a task. So var task1 equals new task. And really, the only pieces of information I'm interested in right now are the name and the user. Because ultimately what we're going to do is notify the user when something changes. So we're just passing in name and user. And then we're going to do a task1.save. So now when I run this, we're just saving task, create a demo for the constructors. And that's coming out of save. All right, so we've got our task set up. The idea here is we want to add 3 observers to this task so that when I run save, now those observers are notified and they get to do their own thing. All right, now let's create our observers that want to observe task. And if you recall from our slides earlier, we've got 3 observers. We've got the logging service, the notification service, and the auditing service. And all 3 of these services want to be notified when task changes. So the way we're going to do that is we'll keep it simple just for the purposes of what we're doing here, but complicated enough so that you know it's working. We're just going to create a service. And that's going to be a function. Now on our notification service, we're going to have 2 things. We're going to have a message. And in this case, it's the notification service. So we're notifying. And then we're going to have a method. And this method is going to be update. And update is going to be what's called when task changes. So when task sends out a notification to all of its observers, update is what's going to be called. So in this case, we're going to send in task. And we're just going to write out a simple message to the screen saying message, so we can look at our closures and see that, hey, var message is coming through. Task.user for task, task.name. So all of our notification service for right now is going to do is just write out to the console, hey, task changed, and I'm letting somebody know about it. Now we're going to do exactly the same thing 2 more times with a logging service and an auditing service. The only difference between these services for the purposes of this demo is that the message is different. If you just copy and paste notification service and change message to logging and auditing, they're pretty much the same thing. I just want you to see 3 different observers, and then we can add and remove observers later so that you'll see how that works. Okay, now we've got some observers, and those guys are ready to go. We need to new sum up because we're creating these as objects. So we'll actually new these up down here at the bottom. So I've got my notification service, my logging service, and my audit service all ready to go, all set. Now I just have to be able to let them know that something's changed. So let's go look at creating our subject with their observer list. All right, the next piece of this observer pattern is the actual observer list. And if you recall from our slides earlier, the subject, and the task is going to be our subject, has this observer list. And that's going to be the list of observers that task is going to notify when it's done. And this is its own separate thing with add and remove and index of and all of those methods on it. So let's take a minute and build out our observer list before we can add that list to our task object. So back in our main.js file, I've got my task, I've got my 3 services. The next thing we're going to add is our observer list. So our observer list is just going to be an object. It says list, but really is an object because we're going to add a whole bunch of functions to it. So we're going to set it up with the constructor pattern and create it as a function. And really, at its core, the observer list is going to be just an array. And that's it. Now we've got our list. Now that we've got our list, we have to add all the methods to it. So the obvious methods for our observer list are going to start with add. I want to add an observer to the list. So we'll do a prototype. Observer list. The method is going to be add. And we are going to pass into that an object. And in this case, we're just going to return and push whatever is passed in onto our observer list. So as observers are registering themselves, whatever they send to add observer is just going to be pushed onto that list. The next thing we're going to add is get, because if we're going to add, we also have to be able to get. And so here we've got our get method, and we're passing in the index, and then we're just handing it back. So for right now, for the observer list, that should do it for us. We're going to add maybe one or two other methods later, but I want to get to a working point fairly quickly here. So for right now, for our observer list, we've got an add and we've got a get, and that's really all we need. So let's take that and leave it there, and now let's turn task into a subject. All right, now the last piece of this puzzle is our subject. We've done our observers, we've done our observer lists. Now let's create our subject so we can make this whole thing work. Now what we want to do is make our task a subject. But if you've been watching this course long enough, you kind of know my feelings on messing with things that already work. So I don't want to make task a subject by adding observer list and notify to task, because task already works. I don't want to mess with it. So what we're going to do is we're going to wrap task with a subject and make it an observable task. So let's take a minute and let's build out an observable task with an observer list and this notify function. Now, the way we're going to do that, if you remember from our conversation on the decorator pattern, is we're going to create a new thing called an observable task. So let's minimize this stuff, fold it up, and get it out of our way. Now, we're going to do an observable task. So the var observable task equals a function, working the same way that task does. So it takes data and then call out to task. So task.call. And remember, what call does is it allows me to pass this into it and then whatever parameters. So I am just passing the this context of observable task off to task. So now observable task has everything that task adds to this gets added to observable task. And then I also want to do something with the observers. So I'm going to add to my observable task this observers list. So this.observers equals new observer list. And basically I'm just newing up an empty array. If you look at observer list, it's just an empty array, this.observer list. That's all it is. So now that I've got an observable task, I'm going to add a couple of methods to its prototype so that we can start dealing with observers. And the first one is going to be to add an observer. So in this case, we've added an add observer function, and we're going to pass in to that function observer, and then just add whatever's passed in to our observer list. And this is what's going to be executed when we do notify. So notification service is going to pass in, if we go back up to notification service, what it's going to pass in is this dot update. It's going to pass in update, and then that's what's going to be executed when we do notify. All right, so I've got observable task and I've got add observer. Now we want to add notify. And notify is going to be a little bit more complicated. So we've got a function called notify, and we're passing in a context. So whatever the context is that we want to do. In our case, we're going to pass in task, because task, when task calls notify, it's just going to pass itself in as the context, so that when my alert gets called, update, notice I'm asking for a task. I'm going to do task.user. So my context in this case is always going to be task. Now I'm going to loop over that array. The first thing I'm going to need when I loop over the array is how long my array is. And we didn't implement a count yet. So let's implement a count. So observer list.count, just to get the length of how long our observer list is. So we've added the prototype account, which is just going to return observer list.length. And I don't have to hide all this stuff. I could just access that array directly, but I'd rather go through the motions of adding helper methods so that we're protecting our array a little bit. All right, so now I've got a count. So now back down here, I've got my observer count, and now I'm just going to loop. So I'm just going to do a simple little for loop that's going to iterate over my observers. And then for every observer, I'm going to go and get whatever they've passed in, and then I'm going to execute it with my context. So basically what that means is I have allowed objects to add themselves to me. So add observer, I'm adding observers, and then when I hit notify, I'm just looping over that array of observers and calling whatever's been passed to me. I'm not checking to make sure it's a function. I probably should do that, but add that in if you would like to. All right, now I have to call notify, and I have to figure out what I want to notify on. So if we go back and we look at task, it's got two methods. It's got complete and save. So let's say when save is executed, so whenever you save something, I want my, scrolling back to the top, I want my notification service, my logging service, and my auditing service all to know about it. So I am going to overwrite my save method on task. So observable task, my method name is going to be save, and that doesn't take any arguments. So if you remember how to do an overwritten method, the last thing we're going to do is actually call task.prototype.save, and we're going to do a .call so we can pass in our this context. And since we don't have any arguments, we're not passing in any arguments. Now, before I save, or maybe after I save, you could do it either place, I want to notify. So I'm going to do a this.notify. And I am, for my context, remember, I'm going to send my task. So I'm just going to send in this. So that way, whatever method is getting called with my this context, not as their own this context, but just so it has access to my this. And in this case, what we're doing up here is task. So now that I'm doing a this.notify, everything that adds itself to my observable task is going to be notified. The last piece of this is to change task 1 into an observable task. There you go. Now, nothing really should change. Everything should still work with my task. So now task 1's an observable task. It's got notify on it. All that stuff's done. Now we just have to register our services on our task. And the way we're going to do that is we're going to do task1 dot add observer and pass in whatever we want observed. So in this case, it's notification.update. Not an executed notification.update, just pass in the function itself. We'll copy that and add 2 more because we want to do our logging service and our audit service. So now when I save, I should get a notification, a logging, and an audit all working for me. So if we look at this and we run it, if I do node main.js, what we'll see is our 3 notifications. We'll see notifying user for task. We'll see logging user for task, and we'll see auditing user task. So let's run this and see if that works. So there we go. Notifying, logging, auditing, and then the task. So this is the observer pattern. This is how that works. Task 1 keeps a record of all the observers and then notifies everybody that they're there. There's one more piece of this I want to do though. Let's add an option to remove observers so that an observer can opt out of receiving notifications. Now, the last piece of the observer pattern is the ability to remove observers or allow an observer to no longer get notified of changes that are being made. And there's 2 things we need to add to our observer list in order to make this happen. One is the ability to remove at a spot. And we're going to add a method, remove at, that takes the index, say, hey, I want to remove at this, and then splice our array by removing one item at that index. Now, the other thing we need to know is where that index is. We have to be able to find an observer in our list. So the way we're going to do that is with an index of function. And we're going to basically just loop over our observer list until we find something that is equal. And we're used triple equal, so it's the same thing. I'm looking for something that is the same, instance-wise and everything, of this object. And so when I find this object on my observer list, I'm going to return that, and then I'm going to splice it out. So let's, on our observable task, add a remove observer. So observable task, and our method name is going to be remove observer, and we're going to take in what that observer is. And the functionality here is really quite simple. We're going to take those two methods that we just created, we're going to drop them in here. So we're going to remove at wherever that observer is. So we're going to look for the index of that observer, and then we're going to remove that observer from the list. Now let's try that out and make sure it works. So down here at the bottom, I've got my 3 at observers, and then I'm going to do my save. I'm going to do a task1.remove observer. And let's remove our auditing service, because that sounds like a bad idea and you never want to remove auditing, but we're going to do it anyway. And we're going to run save again. So now the first time I run this, I should see all 3 get updated. After I've removed an observer, I should only see 2 get updated. Real quick though, we need to change this to audit.update so that we're removing the right thing. Here we're adding an add observer, audit.update, so we remove audit.update. Now let's try this out. And what you'll see when we run this is that first I have notify logging and auditing, and then I save the task, and then I have notifying and logging with no auditing. If we go back over and we change this to our logging service.update, and we run it again, see, this time we've got notifying, logging, and auditing, and then notifying and auditing with no logging. So that's how that add and remove works. That's the observer pattern. That's how this whole thing works. I've got 3 things that want to be notified when a change is made, and essentially I'm just adding a function to a list of observers that our task is executing every time a change is made. The next pattern we're going to talk about is the mediator pattern. And the mediator pattern is an object that controls communication between objects. So really neither object has to be coupled to the other objects. If you remember the observer pattern, the observer didn't really know much about what was going on with the subject, but the subject knew about everything. So the mediator pattern is a little bit of a resolution to that thought. So think about it like this. The mediator pattern allows for a loosely coupled system. Neither side has to know very much about the other side in order for this to work. And one object manages all of the communication. Think about it just like a mediator in a conflict resolution. If you've got a strike going on and they call in the mediators, well, the mediators are the one that manage all the communication. So everything that needs to be communicated goes through the mediator, and then they send it out. And this really allows for a many-to-many relationship, because I can have several objects publishing events and several objects receiving the notifications from those events, and it all flows through one spot. So if we look back at the observer pattern, the subject was sitting on task, and the observer list was there, and notify was there, and it was responsible for pushing everything out to the other services. And that can be maybe a little hefty. If you watch the flyweight pattern piece, we talked about memory management, and adding more stuff to something I'm going to replicate a lot of maybe isn't the best idea. Well, the mediator pattern splits all this out. So now the task pushes events to a mediator, and that mediator looks at everybody who's subscribed to that event and sends notifications out to everybody that's subscribed. And the mediator can do a lot more than just that one shuffling of information. They can manage that communication and make decisions based upon information that's coming in. All right, so let's build out this mediator pattern using all the same pieces we did from the observer pattern. So if you look at what we've got our task, which is the same task we've kind of been using all along. Just name, user, completed, all that with the 2 functions, complete and save. And we're going to leave that intact, and we're just going to use that the way we have been for the last couple of examples. Now we've got our three services, our notification service, our logging service, and our auditing service. And those are the same exact thing we used before. So they just each have an update method that's just going to write out to the console. Although in practice, you would call a service or you'd call an API or go to the database or something. That update method would do something along the lines of whatever the service is for. Now we're creating a new task, create a demo for mediators with a user of me, an instance of our three services. Now, the piece to build out is our mediator. And remember, our mediator is just going to kind of sit in the middle and it's going to manage everything for us. So the first piece of building out the mediator is to get it set up. And we are going to use the revealing module pattern for our mediator. So we want mediator is going to equal, and we're going to just wrap it in an iffy. So function, and then we're going to immediately execute it. There we go. Now our mediator is going to have a couple of pieces to it. We're going to have channels. So you can publish or you can notify to a specific channel. And that's really what everything's built around here. So we've got channels, and that's going to be an object. And then you have publish and subscribe. So let's do publish first. Or actually, let's do subscribe first. And that's going to be a function. And you are subscribing to a specific channel. And just like over on the observer side, we're going to have a context. And then we're going to have a function. So this would be like the callback. I don't like to call it a callback in this situation because it's a little different. Although some would say it's exactly the same thing. But I'm going to call it a function that we're going to execute. Now, when we subscribe, we're going to either add the channel or we're going to just add this subscriber to the channel. So the first thing we want to do is actually check to see, hey, if this channel doesn't exist, well, let's create that channel. And once we've got that done, now let's actually add to that channel. So we'll do mediator.channels, subchannel. Now, you may be tempted to think that this is an array because I'm using bracket notation, but this is an object. So don't get confused and say, hey, channel's an int here, because it's not. Channel's a string here, and I'm just using bracket notation on the object, not bracket notation to pull in an integer. Since we're really having a list, it's easy to get confused into what that would be. Now, then we're going to push. Now, the subject of that specific item in the object is going to be an array, and we're going to push onto that array the context and the function. And that really is all that is happening on my subscribe. So recap, subscribe is just a function that's going to create a channel if it doesn't exist already, and then push the context and a callback function or just a function onto an array by that channel. The other piece of the mediator is the publish. So it's pub subscribe, right? So publish equals a function, and this time we're just going to take the channel. Hey, channel, go. Now we are passing more into this than just the channel, but I don't know what we're passing in because we're calling a function. It could be anything, so I'm not going to restrict it right here. And I'll show you how we're going to deal with that here in just a second. So the first thing we want to do is, make sure this channel exists. So we'll do a little bit of checking. We're not going to do a lot, but just so you can see how it works, we'll just pop that in there. Now, if that channel exists, we want to loop through everything that is involved in that channel. So we're going to do an if I equals 0, so we're going to go less than mediator.channels.length, so however long that array is, I++, not if, for. Okay, now for every subscriber to that channel, we're going to execute that method that was called. So for every subscription, mediator.channels, channel, sub I, for every subscription, we are going to execute that method. So sub.func, the function that was passed in, .apply. And the reason we're doing apply here is we're going to pass in the context, sub.context, so whatever it sent to us, and then the args. Now the args we haven't gotten yet, But this is, the args are going to be everything else that was passed in. So when I publish to a channel, I'm also going to send a whole bunch of other arguments with it. And we need to get those. So outside of the for loop, those aren't going to change. We are going to add var args, and it's going to be a slice of arguments. And the reason we're slicing off arguments, so arguments is all of the arguments that are passed into the function. We're going to hack off the first one because we already know it. That's channel. Everything else we want to put into our arguments, and we're going to pass that into our .apply. So basically what we've just done is we are calling the function that was passed into our mediator with whatever context it passed in and whatever arguments were sent. Now that's our whole mediator. Remember, on our observer side, we had a whole bunch of stuff. On the mediator is much simpler because it's really just going to pass things around. You can make the mediator a lot more complicated, but we're going to keep it pretty simple for right now, just so you can see how it's done. Now, I've got my methods. Our revealing module pattern says I've got to now return those methods. So I'm returning the channels, subscribe, and publish. And I'm returning the channel so that I can get access to it again later, because I'm just declaring it as a variable and I'm doing mediator dot everywhere. So just a slightly different look on the revealing module pattern that we've had up till now. Okay, so now that we've got our mediator, let's fold that up so we don't get confused. I've got my task, I've got my services. So now let's start adding things into my mediator. And to add that, we just do mediator dot subscribe. And I'm going to subscribe to the complete channel. I could subscribe to whatever channel I want. It doesn't matter, remember, because if I pass in a channel that doesn't exist, it's just going to create it. So when I do a mediator.subscribe complete, it's creating that channel, and I'm going to pass in my notification service, and I want to do update. So when it executes the update function, remember it's doing apply using that notification service. And let's do two more. Let's do ls and audit. All right, so all three of those are subscribed and ready to go. The only thing that I still have to do is publish to the complete channel. And we're going to decorate task one. We're not going to do full subclassing. We're just going to decorate task one so that it's calling to this channel whenever complete is happening. So let's do this. Task one dot complete is going to now equal something else. And I'm overriding that function with a new function. And the first thing we're going to do is a mediator dot publish. And we are publishing to the complete channel, and we're passing in this. So the context of task one. And so remember, if you look up at our actual publish service, so let's blow this back out. If you look at our publish service, it only takes channel. We didn't pass in the task. Well, we're passing it in. That's why we pull out the rest of the arguments and then pass them in when we do the function.apply, because now I'm passing in that task that's going to be necessary for my notification service, logging service. They're expecting a task to be passed in. Okay, so mediator.publish this, and that's great, but now I've overwritten my task1.complete. So we've got to call task1.complete. So that's actually coming off of the task.prototype.complete, and we're going to do .call and pass in this. So I'm calling the complete function with the this context. And now we're doing this to complete instead of save, so we'll change this to complete. Okay, so recap real quick. We've got three services: our notification service, our logging service, our auditing service. That's the same that we had in the last one. We've built this mediator, and all the mediator is for this. You can make these a lot more complicated, but all it is for this is just a subscribe method and a publish method. And then a list of channels, and that list of channels just has a channel name with an array of subscribers. And so mediator.subscribe adds our services to the subscription. Mediator.publish sends a message and a context to everybody that subscribed to that channel. And then task1.complete. So when I run this mediator, you'll see notifying, logging, and auditing, and completing task. So I have subscribed to a complete, and I have now executed those three subscriptions when I did my task1.complete. So that's the mediator pattern. That's a simple version of the mediator pattern. You can make this significantly more difficult if you want to, and put all sorts of decision points in on everything, and you can manage all that here in your mediator. But beyond this basic framework, pretty much the sky's the limit. But once you get this framework to work, you can do whatever you want with the rest of this pattern. Now, the last pattern we're going to talk about in this course is the command pattern. And the command pattern is just a way to encapsulate the calling of a method as an object, as its own individual thing. And the reason why you would do this is it allows for fully decoupling the execution from the implementation. Up until now, when we've had services, I have to do service.save, and I have to understand in the task object that service has a save method, and here's the parameters necessary for that save method. And that's a little coupled. We're going to decouple that and make it so that we're just executing an implementation. And this allows for a much less fragile implementation. If I want to change something on my service side, I can, and not have to worry about if I change a word or change an execution of a method. I can deal with that over on the service side. And also, if you read the Gang of Four book, it allows undo operations. I can store a state before I execute a method and then revert state if possible, and I can handle all of that as part of my execution. And the last piece is it supports auditing and logging of operations, so I can log what operations are done in one central place. I can log what operations have been done so I can rerun them if necessary or audit them. And if you've been paying attention to my icons over on the side for each one, I picked the USB symbol for this one because that's kind of the idea that we're looking for. I want a standard interface to execute everything. And the command pattern kind of lets me do that. It lets me pull out the concrete implementation and just give me a generic interface, kind of like what a USB is, a generic interface into my services to execute commands as needed. All right, now let's take a look at how to implement this command pattern on one of our repos. So I have pulled over from module 3 the task repo we were using when we were dealing with our task object. And basically all this repo has is two methods, the get method and the save method. And those will do things for me as we go. But what we want to do is we want to eliminate the need to know it's got a get method and a save method and work that a little bit differently. So what we're going to do is we're going to add to this repo an execute method. And this execute method is going to take the name of a method that we want to execute. And I don't care what it is. It could be anything. And then it's going to run some stuff. So what our repo.execute is going to do is it's going to actually call the method for us. So if repo subname exists, then we're going to call that with the .apply. Now, if you've been watching the whole thing, you'll see I'm using call sometimes and apply sometimes, and there's a reason for that. I like to use .call, and I can pass in the context, but .apply allows me to just pass in an array of parameters. .call, you have to list out each parameter individually. .apply lets me pass in the array of arguments right here in the second parameter of .apply. So that's why sometimes I'm using .call and sometimes I'm using .apply. It depends on the context of what we're doing. Speaking of which, I need an array. And so that's what we're going to put right here is the same thing I think we've done this once before. Var args equals the slice off of array. And I've spelled it out, array.prototype, just so it's obvious. You can just do that. Array.slice.call arguments. I'm just being more explicit. And I'm cutting off the first one because we already are using that one somewhere else. Now, if that exists, I'm going to call it. And if it doesn't, I'm not going to call it. And then we're just good. Otherwise, I'm going to return false. So the way I deal with this is I call repo.execute in order to execute a method on that repo. And in this case, let's do save. And I can pass in a task object that I want to save to the database. let's just pass in something, a task with an ID, a name, and whether or not it's completed. And that for right now will be the task that we're going to work with. Now, when I run this, you'll see we get saving task 1 to the database. So the way the command pattern works is I just pass in as a parameter the method I want to call and then the object that I want to call it on. Now, this seems to be a little bit more complicated, so let's build this out a little bit so you start to see why we might use the command pattern. We'll start by adding an actual repo of tasks, and so we'll just do this. We'll say tasks, and that's going to equal an empty object. And we'll do commands, and that's going to be an array of all of the commands that are executed on this repo. Now, when I execute save, let's actually save to my repo what we're saving. So let's do repo.tasks sub task.id is going to be equal to the task that gets passed in. Well, it'll just be our repo that we're going to use for right now. We're just going to save every task under its task ID back into our repo. Now that we have that, let's come down here into the execute and let's drop a push in here. So now repo.commands.push, we're going to push the name of the command and whatever it is we passed in. So that way we're going to end up with a list of commands like save and get and all of those and the object that was passed in. Now for this one, we're just going to kind of keep it simple. Remember, args is going to pass us an array, and I just want the object that's passed in. So we're going to take the first one, arg sub 0, and drop it in there so that we have our object. Okay, now when I run this, I'm going to have a list of commands and a list of objects. Let's build this out just a little bit more. And instead of just 1, let's run 4. So now I've got 4 executes creating 4 tasks. And just down at the bottom, we'll do a console.log and we'll add in our repo.tasks. Now let's run this again and you'll see we have 4 tasks now in our database, our repository, task 1, 2, 3, and 4, and the full task. Now here's the beauty of the command pattern. I have in my commands object, my commands array, all of the things that have been done to this repo since it was created. And if something catastrophic were to happen, like I don't have a database connection or an error happen, I actually have the ability to rerun those commands again in order to make this work. So let's play with that just a little bit so I can show you what that looks like. We're going to create a new method on our repo called replay. And that's going to be a function. And what replay is going to do is run over our commands and re-execute them. Now there's one issue with this in that I'm executing, and in my execute I'm logging it in my repo command. So let's actually create a new method called repo.execute_no_log, which is basically repo just without this one commands.push. So we're executing it, but we're not logging it because we don't want to create an infinite loop here. All right, so now what's going to happen, recap real quick, we created a replay function that is basically just going to loop over the commands and rerun them. And we're going to call execute no log in order to make this work. Now let's come down to the bottom and let's try this out. So I'm going to log my tasks. Then I'm going to go repo.tasks equals empty. That's bad. I just deleted everything in my repository. And I'll prove that to you by logging this out again. Now don't worry, I can do that because now I can do repo.replay. And all that's going to do is rerun all of the commands that were executed against my repo. And I'm going to run it one more time. I'll run my logging one more time, and you can see that this worked. So let's try this one more time. Let's run this, and what you're going to see is you're going to see the full list of tasks, you'll see nothing, and then you'll see the replay of tasks. So look at this. Check this out. You've got saving 4 tasks. There's the 4 tasks. Then you've got nothing. Then we ran our repo.replay, and look, we've got our saving 4 tasks again, and our 4 tasks are back in our repository. So what this command pattern allows me to do is log all of the commands that are executed against my object and then rerun them as necessary. And actually, another thing we could do if we wanted to take the time is I could do a get on my task. So if I save a task, I could do a get first, just in my save, and store the old version in my command. And then I could do a rollback that would then just save the old version. There's all kinds of things you can do with this command pattern when you start treating your commands as a full-blown object. All right, we have made it. We have come a long way in our discussion on design patterns in JavaScript. This isn't all the patterns in the Gang of 4, but what I did is I picked out a bunch that are used in JavaScript most often. There's probably some other ones that you might come across, but these are the majority of the JavaScript ones that are used. We started out by talking about objects and how objects work in JavaScript, because they're a little bit different. They don't work exactly the same way as they do in everything else. And so that was a good way for us to just level set on how objects worked. Then we talked about the 3 kinds of design patterns: creational design patterns that were involved in creating new instances of an object, structural patterns, which deal with the makeup of objects and how objects look and interact with themselves. And then we ended with the talk of behavioral patterns, and we looked at 3 patterns that help objects interact with each other and how communications flow between objects. I hope you've enjoyed this course as much as I've enjoyed making it. This has been a fantastic course. I've had a lot of fun. Hopefully you've enjoyed it and you've gotten something out of it. I'd love to read your comments down in the discussion area if you've got any. Just drop a line down there and let me know if you've got any questions. I'm looking forward to the conversation.